Is this it? Are we live? Hello? Hey, everybody. I assume we are broadcasting now. I can see there's 22 bright-eyed and bushy-tailed learners out there. And so thank you again. Feel free to say hi in the chat just to make sure I know I'm not alone out here. And so what we are going to be doing today is we'll be a little bit more organized today. What we will be doing is we'll be sort of recovering the stuff I talked about in the intro to electromagnetic radiation video that I posted. Oh, hello. Good. Excellent. There are people there. Good. I thought I was alone. And, what I'm going to do is hopefully you've watched the video. I know. Oh, yeah, by the way, Renee had a birthday. I'm working on birthday rockets. Oh, look. Okay, there are people here. That's nice. Okay. The elites are here. So what we're going to do today is I will kind of like go over the video like I would have in class, adding some extra information. This will be a little bit more organized than yesterday. Probably not as organized as it could be, but I will continue to work on this. Oh, good. There's Lindy. Hello. Millen. Good to see you again. Renee. Alex. Good. Excellent. Good. Nice job. Bree. Hello, Bree. Some of you guys have emailed me. I just noticed I just opened up my email. Some of you did email me since yesterday. I did not get back to you. I apologize. I was working on other stuff and then working on the presentation this morning. But rest assured, if you did email me, I will email you back. And as with yesterday, if you don't want to talk in the chat, that's fine. Just email me and I'll try to answer your questions there. We're lucky. This is actually a very good lesson. There's a lot of very neat stuff that we can do with the electromagnetic spectrum. So hopefully you will enjoy some of the things that we can do today. That would be a lot of fun. And if you have questions, again, ask them in the chat and we will try to answer them as best as we can. I will try to continue to do some emoting here with my guy over here, but I only have two hands, so don't expect too much. Hold on. Let me adjust something here. My arms seem very unnatural here. I'm going to adjust my arms a little bit to get a more natural stance here. There we go. There we go. Now I feel a little bit more natural there. All right, so here's what we're going to do. I don't want to belabor this too much. So let's start with some housekeeping stuff. Again, obviously there has been some questions about due dates. That's completely understandable. I get that. Normally everything was due at 7 a.m. I thought 7 a.m. felt very unfair for remote learning. The day isn't starting at 7 a.m. And so I think it makes sense. Lena, hello. It makes sense to have the due dates for assignments be, or the due times, I should say, when office hours begin. And that way, if you get up in the morning and you haven't done your work yet, you still have a couple hours to do that. Now, the only problem with that is that obviously our office hours are going to flip from 10 a.m. to 11 a.m. every day. But it is what it is. I didn't want to make it 10 a.m. every day and then you get cheated out of some time. So again, video quizzes and MCs will be due at the beginning of office hours for the day. Now I might mess that up as I set stuff up in Pearson. If you have made a boo-boo up to this point because you did not realize when the due date or due time was, just email me. I will reset that quiz for you. And so that you won't miss any time on that. Don't forget also about the optional reviews on Pearson. Again, these are all on Pearson right now. I don't have any Blackboard assignments yet. That will change probably in the near future. So if you want to do the extra credit review, or the optional review, I should say, again, those are all on Pearson. So if you don't know about, hello, Maddie. Hello, Nikki. Koki, good to see period 7 in the house. If you have the desire to do that extra work, which I think is a good idea, all of that stuff is on Pearson. So when in doubt, go to Pearson. That's where the assignments are. You will see them on the calendar. This should not be an incredible surprise to you. So make sure that you just look on Pearson for that stuff. I am still grading the exams. I've been working on trying to get this stream up and running. So I have been cobbling away your last exams. I don't have any more news on that. Anyway, just also for the good of order, don't forget to use your book. Tro is an excellent resource. You should be reading your book. It is a vetted, edited resource, so use that. And then also, there's plenty of summary problems in the back, multiple choice questions in the back, practice problems in the back. I'm going to assume that all of you are going to sort of settle into the work ethic that you find appropriate for your future in chemistry. So if some of you are just honors students who are just trying to get through an honors class, I'm going to try to be respectful of that and try to make assignments based on that. Hello, Theo. If you are planning to have a future in science, then of course it will be incumbent upon you to keep that training going. So you should be doing extra work, doing extra problems, doing extra research. Obviously, what we'll be doing is sort of minimal coverage. And so please prepare for your future. If you want to go into medicine or science or chemical engineering, then I'm assuming you're doing more work than that. And if you are not one of my students and you've stumbled upon this channel, welcome. You don't have to do any of this work. And I am also working on some birthday rockets. Graphics, we'll see. That will be continued too. So I will watch the chat for a second here to see if there are any bookkeeping questions, and then we will continue on with the lessons. We may not get through this today. The electromagnetic spectrum is very exciting, and many of you have not really thought about it. Again, not your fault. So again, I'm watching the chat. I don't see any questions yet. There will be a little bit of a delay here because of latency. So I will pause. I will emote. There, check that out. A little flex for you there. I will try out some of my, here's my sad. Now I'm disturbed. You've made me sad. That's pretty good, huh? Smiling. Uh-oh, someone forgot to do their homework. Oh, Corona. There you go. You've seen my emotes. All right. Okay. So that sounds like there aren't any questions. So let's move on. All right. So our next thing we're going to do is talk about a little bit about the properties of a wave. So let me get this stuff out for us here. So many of you have learned about waves perhaps at some point. Oh, are we going to have a nomenclature test? That's a great question. Probably we're going to have a nomenclature test again. I feel like people want that. I'm not sure how to do it equitably. But yeah, I think we can. We'll figure something out for those of you who want some nomenclature points. Yes, we will. How we'll do it, I don't know, because obviously every single one of you knows that you could just Google answers. So in some ways it seems rather unauthentic to just give you credit for Googling stuff. Yes, we will do a nomenclature review also. I might do that in the evening or on one of the off days, Maddie. But yes, we will definitely review nomenclature. We'll have something dedicated to nomenclature. That's a great question. Are the 9 weeks going to end at the same time? Probably. I assume they will probably end it at the same time and then lock it down. Probably. But I don't know. When I know, you'll know. That's a great question. I think that's that it. It was April 1st, so I don't know if it's still April 1st. Lindy, I don't know if the quarter is going to end April 1st or not. So that was a good question. I think it's April 1st. Yes, I think Bree is right. Good. Those were good questions. I'll keep looking for that kind of stuff. All right, okay, so here's the deal with waves. Let me get my little pen out here. Let's get a little brush out here. Sorry, you're going to see a brush pop up in your window there. I apologize for that. I'll do it in red. All right, so many of you guys have learned about waves probably in, I assume, 8th grade. 8th. Uh-oh, where's my pen? Things are already falling apart. Oh, I'm drawing in the wrong one. Here we go. In 8th grade. Right? Many of you learned about this in 8th grade, I bet. Here we go. Let's write that. Oh, no, that's not in red either. Yeah, there we go. See, Anico mastered colors. So in 8th grade, many of you guys probably learned about waves. Remember, there are 2 types of waves. There are longitudinal waves. These tend to be like sound waves and things that you've got, or like earthquakes and stuff. And so you've got a compression and expansion, refraction of the wave. These tend to be traveling through materials. And so we hear sound waves as you make a noise, you vibrate the air, it compresses, and then that energy works its way through the air, which is why you can't hear sound in space, because there is no atmosphere to propagate that wave. Those are not the kind of waves we are going to be talking about today. The electromagnetic spectrum is a great example of a transverse wave. And so the idea is that we have crests and troughs, we have wavelengths and frequencies, we have amplitudes, we have a lot of things And this is going to be the energy of this wave. And so that's the important thing to understand, is that we are not talking about longitudinal waves right now. So again, think about a wave in a pond or something like that. And that's a pretty good example of that's a duck right there. Sorry, that's not as good as my hamster. And so that's the kind of waves that we are going to be thinking about there. All right, and so that's the basic ideas of just what a wave is. Now, waves are going to be different for the electromagnetic spectrum. So this is a very important differentiation between other types of waves. There are lots of waves out here. Oops, here we go. Now we're on the right screen. Is this working? Yes, this is working. And so with the electromagnetic spectrum, with an electromagnetic radiation, it is still a longitudinal wave. So notice you'll see the ups and the downs, right? So that makes it a longitudinal wave, or a transverse wave, I apologize. But what makes electromagnetic radiation different, and you do not have to worry about this at this level of science, is that, again, we have alternating magnetic and electrical fields, so hence the electromagnetic radiation. And this is very interesting, extremely fascinating. You don't really have to worry about that so much at this level. If you are going to continue on in physics, this is definitely something that you're going to want to pay attention to. But that's what makes the electromagnetic radiation different than other types of waves. This does not require any kind of medium for propagation, right? And so the light that you get, for instance, is classic electromagnetic radiation. It travels through the vacuum of space. In fact, what makes electromagnetic radiation special is that, again, it travels at the speed of light in a vacuum, and that was in your notes. And that's an important caveat. Electromagnetic radiation travels at the speed limit of the universe, c, which we call the speed of light, but it's actually a universal speed limit, and that is in a vacuum. You will find out that there are things light can travel through that will slow it down. And so don't get freaked out about that. That doesn't change the universal speed limit, c. And again, if you are interested in where that comes from and what c is, I would recommend channels such as like PBS Spacetime. They are pretty advanced, but there's lots of fascinating information about the electromagnetic spectrum. And so that's the basics of what makes electromagnetic radiation different. All right, and so that really gets us into the ideas of waves itself. Let me see what I got here. You know what? I should probably just talk about it here. Hold on. Let me just see what my next slide is here. Yeah, no, let's stick with this slide then. All right. So what we are going to do then is just talk a little bit about waves here. And so again, and you know, it's the important things that you guys need to understand about waves here, right? Is that, again, we have what's called a wavelength. And again, you, I guess, cosine, sine, right? You guys are going to get excited about this, right? Again, waves have what's called a wavelength, and we're going to indicate that with lambda, right? So that's your wavelength. That's very important. It's one of the things that you'll see a lot when people are talking about electromagnetic radiation. All right, that's pretty obviously, that's going to be the length of the wave, typically in meters, but it can be in anything. Again, prefixes matter. The one thing that you can't see so obviously from here is the idea of frequency. So frequency is the number of times that a wave passes a given point per second. Frequency is represented by the Greek symbol nu, and that's essentially a per second. Obviously, there can be units on that too, and that sounds a little weird, but that's also known as a hertz, right? And so per seconds or hertz, that is frequency. One of the ways that you guys can probably link into that is the idea of radio waves. So if you think of FM and AM, Bob FM, or like your favorite AM station, again, those are going to be at a certain frequency. So Bob FM is at, I think it's for AM, I think it's megahertz, if I remember correctly. And so Bob FM is at 96.9 megahertz. And that's the specific frequency of that, as opposed to, I don't know, what's 96.1? I don't remember what that station is, but those different stations, B94, it used to be called B94, like 93.4, those are the frequencies of that electromagnetic radiation. And so frequency is super important. In fact, you guys could take a moment right now and go find a remote control or a microwave, and you'll see that all of those talk about the frequency generation of that electromagnetic radiation. Now, frequency is a little harder to wrap your heads around. If this was a wave, frequency would be the number of times that the wave passed that point per second. And so obviously, if you had a longer wavelength, then you would be passing that point more often and your frequency would go up. I think one of the best ways that I think you can think about this is think about like a tank tread. So if I have a tank tread, and I'm looking at the tread of a tank, now this is going around in a circle, right? Now, if we have a larger section here, and let's change the color of this, right? So let's say, whoop, I thought we changed the color of that. Let's try changing the color of that again. So if we have a section of green here, right, you could see that the longer this section is, right, if this tank tread was spinning around and you were looking right here, the longer this is, right, the less often you're going to see the next color. But if right next to it, let's say instead that we have blue, and we alternate blue, green very rapidly, then if we look at one point, we're going to see colors changing very rapidly. And so that's kind of the way that you can think about frequency. If you think about a wave, right, and you think about it passing by a point, the more often you see a new wave is your frequency. Okay, so that's the basic ideas of that. And so those are the only two things that we are really going to care about. There are lots of other things that you can measure, amplitude, things like that. But we're not going to worry about that stuff at this level right now. But don't worry, physics awaits you. Again, any questions about just the concept of waves or frequency? Again, I will watch the chat and see if there are any questions about that. I'm not sure what the latency is here between that, but we'll pause for a second. For those of you who don't have any questions about that, feel free to take a look at the electromagnetic spectrum here. It's pretty cool. Okay, so it sounds like there aren't any questions about waves and frequency and wavelength. So the next thing to look at is the idea of the electromagnetic spectrum itself. So let me close all this stuff down here, open this up. So here's the deal. You guys are used to seeing a very tiny part of the electromagnetic spectrum. And that's the thing that I think blows the minds of most students. The light that you see coming off your screen right now, the light, anything that you interpret right now with your eyes, our eyes can detect a very tiny sliver of the electromagnetic spectrum. And so all the things that you recognize as visible light are just certain wavelengths. And the spectrum extends on both sides of that. It's the invisible light, which is an interesting way of thinking about it. It's the light that we cannot detect with our eyes, but still exists. And again, we could spend weeks talking about this. It's neat to think about all the things that you guys thought were different types of energy, or different types of light, I should say, are all the same thing. So X-rays, radio waves, AM, FM, microwaves, the infrared, ultraviolet light, gamma rays, all of these things that you thought were disparate sort of entities in the universe are really no different than red light or blue light or green light. They are just stretched out so that we can't detect them with our eyes. Again, you can, am I back on? It said I was offline. Are we here still? Okay, good. I got worried there. Are we streaming? Are we good? Are you guys still there? Did I lose you guys? I'm going to check here for a second. If you're here, say something in chat. Again, there's a latency delay. I apologize for that. I think there was a hiccup on my side. I want to make sure I didn't lose you guys. I'm going to run under the assumption that you're still here. Oh, okay, good. I'm seeing yes. Okay, good. I got worried there for a second. Right, okay. And so, hold on. Let me shift something around so I can see what's going on here. I apologize. It looked like there was a hiccup on my end. All right, so anyway, so you're back. Sorry about that. So anyway, so we got a sliver of the electromagnetic spectrum that you can see. And so when you look at this over here, like infrared, all right, you guys are giving off, and again, this is so neat, you guys are giving off electromagnetic radiation right now. The heat radiating from your body is a type of electromagnetic radiation that your eyes are incapable of detecting. And so you can actually see people right here. People are a source of electromagnetic radiation. It's just that our eyes can't detect it. Now, obviously, there are things that can detect it, but we cannot. And so there are certain animals that can look into the infrared. If you were fans of like the Predator, like that 80s, alien horror action movie, the Predator saw in the infrared. And then we took that infrared and then turned it into visual light so we can interpret it. So we give off electromagnetic radiation. We just can't see it because, as you can see, the wavelength is longer and it's beyond what we can detect with our eyes. And if we keep extending the electromagnetic radiation, we get into stuff that you cannot see with your eyes, which is like the microwaves. Microwaves are a type of electromagnetic radiation which is longer than infrared. And then we keep expanding and pulling that wavelength more and more and more, and then we start getting into radio waves. First FM, and then into AM. And as I understand it, FM radio waves, again, are in that part of the spectrum because AM radio waves are very good at carrying the information for music. That's why AM radio tends to be a lot more like talk radio and things like that. AM radio is more for music. But all of these things are just pieces of the electromagnetic spectrum. And on the next slide, I'll show you how actually the United States government has actually carved up this part of the electromagnetic spectrum. It's fascinating how every part of the electromagnetic spectrum has been carved up and used for some industry. All right. And again, this isn't even complete. Your Wi-Fi router right now that you're listening to, again, is transmitting at a certain part of the electromagnetic spectrum, which is why sometimes microwaves interfere with Wi-Fi, which does in my house. Your remote controls, all of these things must buy a part of the electromagnetic spectrum and then broadcast on it, which is fascinating. And if we go to the other side of the electromagnetic spectrum on what we can see, then we start running into things that are higher energy. As it may make sense, right? If you have a long wavelength, you tend not to have as much energy as something that has a really short frequency. Short frequency is going to mean higher energy. And so things on this side of the electromagnetic spectrum have much lower wavelengths and therefore much higher energy, which is why, again, we obviously don't want to get hit by the we don't get hit by ultraviolet radiation, high-end ultraviolet radiation, X-rays, and then all the way to gamma rays. We all know gamma radiation is bad. Obviously, that's what made the Incredible Hulk. Even beyond that are the idea of cosmic rays, which I understand are quite like other types of radiation. But as the frequency gets higher, as the wavelength gets shorter, then the electromagnetic radiation becomes what's called ionizing. And so again, if we go to like, I think pretty much around here, anything past this N is what's called ionizing. And this is the kind of electromagnetic radiation, if you get hit with, can knock electrons off things in your body, can cause damage. Which is why at your dentist's office, they, when they take an X-ray of your face, or they leave the office so that they aren't getting exposed to the X-rays. Now, again, the amount of ionizing radiation you get from an X-ray or something like that is minimal. We wouldn't want to live in X-rays. When people started realizing that it's ionizing energy, then they didn't use X-rays for gratuitous things. In the early days, they would use X-rays for everything. If they wanted to find out what shoe you would wear, they'd use X-rays and things like that. Those days are over. But I would avoid unnecessary X-rays, but there aren't that many unnecessary X-rays. Same with CAT scans, things like that. These types of radiation are useful. We wouldn't want to get them all the time. And again, there are charts out there if you want to look at it. We are all being exposed to ionizing radiation. Just living every day, there is ionizing radiation in the background, flying on a plane, things like that. So I don't blow it out of proportion. Now, I should point out ionizing radiation is different than nuclear radiation. Unfortunate terms, when things undergo radioactive decay, which we talked about, there's alpha, beta, and gamma radiation. These are things that are being emitted from atoms. Gamma radiation is an ionizing radiation at the far end of this. Okay, so gamma radiation is a high energy electromagnetic radiation. But other types of nuclear radiation are actually particles. Alpha particles, if you remember Rutherford, that is essentially a positive helium nucleus. So it is being radiated from the nucleus, but it is not electromagnetic radiation. It can be stopped by paper, for instance. So the term radiation is used for different things. Beta radiation is high energy electrons. Still particles, still have energy, but different than gamma. So just keep that in mind. Anything over here is what's called non-ionizing. And so that's why you really shouldn't be scared of your microwave or your cell phone. These things are long energy things that aren't going to be ionizing radiation. And again, there's a link in the weekly assignment sheet to Do Cell Phones Cause Cancer? Essentially, long story short, there's no evidence of it yet, but we haven't looked in every corner of study yet. Because it's a longer wavelength that has less energy, so it's not ionizing. But again, the jury is still completely out, but most of the evidence doesn't show anything conclusive. Microwaves, interesting side note, even though microwaves have less energy than the heat that you give off from your body, microwaves cause water molecules to vibrate, sort of like a singer who can sing at the right note to shatter glass. Microwaves radiate at the right energy to excite water molecules, which is why it can heat things up. And so microwaves, again, aren't ionizing, but they just hit the sweet spot to cause water molecules to vibrate and cause heat internally. So I lived in a world before microwave cooking. And so I remember when microwaves came out, they were a big deal. I remember microwave cookbooks. You live in a world of microwaves. But it is what it is. So listen, this has been going on for about a half hour. I think this might actually be a good place to maybe, we don't have to cover all of this today. I'm going to show you one more little slide about the electromagnetic spectrum here. Hold on here. So this is a really fun chart here that shows just a part of the electromagnetic spectrum. Again, this is from NASA. So here's a neat thing here. So this right here, I am not writing. Am I writing here? I'm writing on the wrong thing again. I apologize. I'm using Photoshop in a way I don't think Photoshop was meant to be used. There we go. So this right here is the visible spectrum. So I'll kind of leave you with this here. So again, this is what we can see. Notice that red is over here. Notice that infrared is beyond that. That should make sense. So a lot of students sometimes forget the difference between infrared and ultraviolet. Do not, right? Again, and another important thing to remember is this spectrum does not have to go this way. Every year students get really, really mad at me because I show a spectrum with red on the left. We could show a spectrum with red on the right. There is no universal standard to which side is red and which side is purple. So don't get freaked out about that. Just like the conversion grid. And a lot of you got mad when that got switched around. It doesn't matter which side is red and which side is purple. Look and see, and then sort of get your bearings from there. The important thing to remember is, again, we have red and then we have infrared, right? We can't see infrared, but remember, infrared is a longer wavelength and therefore less dangerous than the other side of it. You give off infrared radiation, right? Which is really cool. You are a light source, but it's in the infrared, which I think is fascinating. We just can't see it with our eyes. And on the other side of that, then, again, we have the ultraviolet. And again, we all know to be somewhat scared of ultraviolet. Again, nothing against the tanning bed industry, but if you are going to go somewhere and then consume ultraviolet radiation, again, that's maybe not the right thing to do with your life. The ultraviolet can be ionizing radiation, which can be dangerous. That's why we wear sunscreen to absorb some of that. That's also why the ozone layer is so important, because that ozone layer is absorbing a lot of that high energy ultraviolet. And we'll talk more about that when I do my little introduction to the sun and how it affects our Earth's climate, so you can become more informed about that. So again, this is a great chart to kind of keep that in perspective. Notice that we have frequencies up here. As we start going here, we start getting more and more energy. There's those cosmic rays up there. And as we go this way, there's less and less. Here's what I thought this was really cool. This is just to show you how we've carved this up, just to show you. This is how the United States has allocated just the radio spectrum. So that's this area right here. Okay. And so look at this. This is how the United States has carved up every tiny sliver of this radio spectrum. All of it is used by different industries, which I think is fascinating. If you want to see this chart in more detail, I think I put a link in the description. You can go in there and just see how every part of this invisible light is being used by some industry. And when some industry stops using this, when some industry becomes obsolete, then that is carved up and sold to other people, which is why you can't just go out and do like pirate radio. You can't just have your own radio station because somebody in this area has bought the rights to that electromagnetic spectrum. And so the radio spectrum is used to transmit information, and then the optical spectrum is used obviously for sight and then also for industrial purposes. But that's higher energy and more dangerous. So anyway, that is a fascinating way to end. I think the electromagnetic spectrum is really neat. There are lots of cool links. I'm going to do a plug for my brother's video. My brother did a series of TED Ed videos, and you can see that video in the link. I won't show it now, so there's no copyright infringement. But check out my brother's video on the difference between ionizing and non-ionizing radiation. There's a link to NASA in there and other things also, which I think will be fascinating. So anyway, so sorry again, I don't like just talking at you guys. What we'll do tomorrow is we'll come back and we'll just finish up and look at some of the math and how we can use these kind of equations. There's not that much math that you need to be responsible for. I think this is a great opportunity to just practice solving for variables, watching for units and things like that. So we'll do those kind of things also. I guess what we can do before we leave today is the drawing was very popular yesterday. So if you'd like a drawing, I guess we can do one more drawing before we call it a day. So if somebody would, I'll take a request, I guess, for a drawing before we leave you today. Let's get my pen ready to go here for a drawing here. Let's see what the chat wants. A dog. Me. All right, me with a dog. All right, I'll show you what. That's fine. I can do that. All right, so a dog. Okay, dog's pretty. That's a pretty easy thing to do. Lots of ways to draw a dog. Let's see. So we'll draw a little dog here. Well, it's going to look probably a little bit more like a wolf here. There's a dog for you there. Whoa, this is a mean-looking dog here. It's a ferocious-looking dog. Here's a dog for you. And then me, I'll show you. Here's a. Let's see. Here, what do I look like now? Looking a little fat in the face today, but it's okay. All right, so I am getting hair back. So I still have my glasses. And I have not shaved during the pandemic yet, but I will. So my beard is actually coming back. So, this is less than impressive. That's not good. That is not winning anybody over today. That is embarrassing. So anyway, so there I am. Whoops, that draw. Yep, that you draw with your black. Oh, you want the hat? That's fine. I'll put on the. That is easy. I will draw on the pork pie hat, which I might have left at school. Draw lost for period 9. I do not want to be involved with internet bullying. I think, let's see, I think it's in my brain. I feel like it's this. Is this loss? I don't know. Is that loss? Is that loss for period 9? Is that loss? Did I do it? I don't think I did it. That's sadness right there. Anyway, I saw it enough. I repressed it. Anyway, so tomorrow what we'll do is if you have questions about the electromagnetic spectrum, please ask it in the chat, I guess, during the warm-up. I'll try to get the chat warmed up early. And then, thank you, Ray. Thank you. I appreciate that. And then tomorrow we'll talk about the math. I think that should be good for now. Please stay ahead on the video quizzes. And I appreciate seeing you guys today. But that's enough time for today. Be kind to your family. And we'll see you tomorrow, I think. So I have a little outro for you. I'm going to try an outro here. Here we go. Let's see if this works. Here we go. We'll see you all tomorrow. Be kind to each other. Keep your social distancing. Keep social distancing. Keep it up.